Before we begin, it's important to recognize that all the cutting and sample making is done on a surface that not only protects the tooling used, but also protects the surface underneath. So the first step is to place the polyurea sample onto the cutting surface, with the UV exposed or the shiny side facing upwards. The 5/16 inch die will be used to cut out a smaller sample out of the original polyurea sample. The following accessories are necessary when the use of tools such as hammers or mallets are used to apply an external force to initiate the cutting. When positioning your cutting tool, keep in mind that you are trying to save as much of the mother sample as possible. Once the sample has been successfully cut, the most efficient way to remove the polyurea sample is by unscrewing the die head and using a pair of tweezers to gently push out the cut sample. Once a sample has been removed from the die head, place the shiny surface of the sample into the custom Teflon mold. Once a sample has been pushed into the mold, we can use the tweezers to gently push in the protruding edges. Now that the sample has been placed into the custom Teflon mold, the first step would be to pour 1.9 grams of acrylic powder into the mixing container. Once this has been done, the next step is to pour 1.2 milliliters of the acrylic liquid binder into the same container. Now that both the acrylic powder and the liquid binder are in the same container, it is time to mix for roughly 30 seconds until the consistency of the solution is uniform throughout. Once the solution has become a bit more opaque and the consistency has thickened a bit, this is a good indication that it is time to begin pouring. Once the acrylic solution is ready, carefully pour it into the mold over the polyurea sample. Once the acrylic solution is in the mold, separate the top lid of the cassette and press the center of the cassette into the acrylic over the mold, allowing the acrylic to seep through the perforations. Now that the acrylic has cured onto the cassette, using a flathead, gently remove the cassette from the mold and place it into a cryogenic chamber. Now that the sample has been cooled, by pulling forward on the lever, mount the cassette onto the Microtome clamping device. Pushing this lever down unlocks the stage. With the left knob, we will position the sample to be parallel with the blade. The top knob fine-tunes the sample to be perfectly vertical. Once we are done, we lock the sample in place. The first step in replacing a blade is to loosen the holder, allowing us to remove the old blade. It is also important to note that all used blades should be disposed of within the specified containers. Now we will obtain our new blade by carefully removing it from the packaging. Slide this new blade into position, with the cutting edge pointing upwards. Now that the new blade has been inserted, we can now adjust the blade angle using this handle. We can also determine what angle we have achieved by referencing the markings on the right. Now that the ideal blade angle has been determined and the new blade has been replaced, we can now tighten the holder. There are two methods of determining the distance between the blade and the sample. The first would be the coarse adjustment, that allows you to move the blade back and forth at an unmeasured amount. The second option is to use this knob for the fine adjustments. This knob allows you to determine the distance between the blade and the sample in the units of microns. This knob determines the increments in which the blade will move closer to the sample, essentially determining the depth of each cut. So at every full revolution of this wheel, the blade will move at that certain increment towards the sample, giving you the desired thickness of each layer in microns. It is critical that the cooling and cutting time intervals are held constant throughout the sectioning process, in order to minimize the effects of contraction and expansion of the sample as it has been cooled and warming up to the room temperature. This will result in consistent layer thickness. Now that the microtome is ready, we can slowly and continuously turn the wheel to initiate the cut. As we are sectioning, we can use tweezers to gently guide this cut sample to prevent any wrinkling or tearing. Once a sample has successfully been cut, we can place it into a clean petri dish and then cover it to prevent any contamination.